Now the iron wire in between that I'm going to add here should draw the electromagnetism towards here. So rearing like this, and articulating the flexibility of the rubber enables it to bend, to deformate. Is this. So therefore the flexibility allows it to deformate, and the turning of the motor, which is able to turn the forearm like the wrist left and right as far as to turn enabled. So the rubber is just for flexation and for attraction force towards this direction or attraction force towards that direction, leaving this at a pitch so that it can tilt on axis. So that's the way the motor. Now I have to wrap it with iron wire and leave these phase wires out from the different parts, from the neck and from the neck. Now I gotta put another brace here. That's the following. The aluminum may assist in high-speed ion displacement, along with the copper. So I got coated copper and coated magnetic wire, copper wire, and I have non-coated with steel, iron wire, and aluminum. So that should assist in high electrodynamic emission. There, I spun the coil. I apply the iron steel wire over the copper coil and over the aluminum, thick aluminum wire. This is the thick aluminum wire which I used around an iron ring, and actually the central of the iron ring. And I spun copper wire over it. I did a couple of Teslas over it, and I added a flux, which is an iron wire, to spun over the top so I could draw the flux towards the central. And that's like my tubular type transformer, but it's just a part to my engine. My engine, similar as this is my engine. Right here I have an iron steel ring, a couple of turns of aluminum wire, soft, pure aluminum wire. Then I have a helix donut, a copper coil, a couple of Teslas. Then I have another steel wire, donut wire, a couple of Teslas, fluxes, magnetic flux lever. Then I have another donut, helix, coil, copper, and spun a couple of Teslas. And I also couple it with an iron ring. So iron ring at both ends. I have aluminum, copper, steel, and copper, and steel ring. So that for my engine to allow that the repulsive force of the iron. The iron is the iron ring. Then I have also an iron wire that's spun alongside, between separating the two copper coil donuts, helix coils, and iron wire coil is spun between it, is central between it. So therefore, this is to give a charge, a DC charge to the copper wire. It should also end a DC charge to the steel wire, and a DC charge to the aluminum wire. Both of them is to receive a DC. The Hall effect, which occurs is in the electron energy winding, where these two phase positive charge are common to one another, or opposed to one another. However, the Lenz law applies to this method to where I phase the point clockwise to cause it to move downward, to flush whatever electrochemicals that I have in the system downward. Tubuloid transformers increase in the spun of the liquid to cause the liquid to rotate at high speeds. That's the reason I have that for the bottom. And the Hall effect, which is received, just increases the Hall effect. The liquid is going to be a ferromagnetic liquid, which has one polarization and is a parallel ferromagnetic liquid, to where even though electrolytes is along with it, but it's going to also have dielectric components as far as elements. That's copper as a dielectric, and aluminum. The aluminum is caused copper powder to break up from the aluminum. The aluminum powder to break up from the copper. However, it created a broader Hall effect, a broader field, so that would flux the transformer within the center of the former. The transformer is what lies alongside the area of the Hall effect. So I'm trying to get the energy to flush downward and to flux the density to the surfaces of the coils and to increase, and that would be actually the ignition switch. So this would be my engine to flux the density of the coils of the transformer, the linear solenoid transformer, and the suspension transformer of the Gauntlet. So this should be incorporated into two separate parts. One part, which just goes into a sink, this tub to where the electrochemical liquid should reside. Now, using sodium eccentric to create a hardnesses to protect the coil while it's in there. So while the mesh flows around within the central, the powder won't touch against these surfaces. So I'm creating a hard density of the plastic. I don't want to use glass in my system. And this is like small size. So I'm going to separate, which is another foundation to go over the Hall effect. And that is because the liquids, if by chance to boil and release to the surfaces where there's breathing hole, I will have a wedge within the center of the platform. However, on the edges, there the liquids will boil up into the surfaces. However, it will go into a slotted area, which is like a ring-size gorge. So a ring-size open clearance. So the open clearance will be like a ring. So if any oil detonation, there it will exhaust. It will explode as a ring shape forth, even as thrust in Hall effect. So because these comments all repulse one another, it increases the electrons to move at high speeds. And because of the liquid crimp, and this is what acts as a liquid crimp, is a tubuloid type diamagnetic, paramagnetic transformer will force the energy, the liquids to move at high speeds, the sodium chloride. So, I'm Jermaine. I'll be back. Bye-bye. So I added the repulsor, and I mixed it with a tubuloid transformer. This is a repulsor design. I'm not finished with it. I have to add other parts to it. I have to add the sodium eccentric within it. I'm going to take it out and show you what it looked like. It's the open clearance. This is the tubuloid transformer, which is behind, which is to drive the electrolytes, and is to drive the electrolytes around the base of a series of the coils, which is repulsive coils, which is actually aluminum, iron, and copper wire. And I have rings, steel rings within it, and I also have aluminum iron wire spun around it. So this would cause, okay, it's not finished curing, so we're still getting wet by quick dry glue. But yeah, it's supposed to drive the liquids around in a rotation, force the liquids down to the frontal, up to the frontal